This is a short introduction to how we determine the intermolecular forces in a given sample, whether it's a pure compound or a mixture of two compounds. So the first thing to note is that we have to identify whether there are ions present or not ion present. If there are ions present, we have to identify if they are basically alone, forming ionic bonding, or interacting with polar molecules to form ion dipole forces. Second, if that's not an option, if ions are not present and only polar molecules are present, we know that they will have dipole-dipole forces. But if there is either nitrogen, oxygen, or fluorine present in the structure of the molecules, hydrogen bonding is likely present. The other option when ions are not present is when we have a polar and not polar molecules. And in that case, the polar molecule can induce a dipole on the nonpolar molecule. And lastly, we have when molecules are nonpolar altogether, and the only forces present are dispersion or London forces. So now, after this very short introduction, let's look at the following problem and let's think of how we can actually solve this problem and propose a solution. So the problem says, what is the strongest interparticle force for each substance? Methanol, carbon tetrachloride, and sulfur dioxide. So take a few minutes to think about this problem. Use the chart that was described before if necessary, although you should be able to remember that. And then compare your solution with mine. Feel free to pause this video if you need additional time. Okay, so in order to solve this problem, we need to understand whether each molecule is either ionic, polar, whether it shows high hydrogen bonding, or whether it's not polar. So we don't need to consider the case of a mixture of a polar and a non-polar molecule because we have only one compound in each of these questions. And once we know the nature of the substance, then we can determine the molecular force or intermolecular force that is present. So let's begin by looking at methanol, part A. So methanol is represented by a central carbon that is bonding two hydrogens and one oxygen and one hydrogen to the oxygen. Recollecting our knowledge about Lewis structures, we clearly identify that that the OH group here has the ability to form hydrogen bonding. So we know that when hydrogen bonding is present, this is going to be the strongest intermolecular force present. Although we cannot neglect that London forces are present, but that these are also weak forces. So now, let's talk about the next part, carbon tetrachloride. So this one, the central atom is a carbon, and we are going to have in a tetrahedral arrangement 4 chlorine atoms. For simplicity in the representation, I will not indicate the tetrahedral shape, but what we can see immediately is that this molecule is nonpolar. Because even when there is a difference in electronegativity between the carbon and each of the chlorine atoms, the geometry of this molecule causes that each of these polar bonds cancel each other out. So therefore the molecule is nonpolar. What we can say then when nonpolar molecules are the only types of molecule present is that the only force that is present in this particular case are the London force or London forces or dispersion forces. For part C, for sulfur dioxide, what is important to consider is the Lewis structure of sulfur dioxide. So we know that this molecule is going to have 18 valence electrons. And if we try to allocate them to the molecule, what we'll end up having is that we are going to have a V shape. Immediately we can see that due to the differences in electronegativity between sulfur and oxide, that this molecule is going to be polar, that the polarity of the bonds do not cancel each other out, so the molecule itself is polar, and therefore, in this particular case, the dipole forces are going to be the prevalent forces. Although we still have to remember that London forces, although weak, they are always present. So in summary then, we can see here an example in which we have hydrogen bonding when there is an OH group, London forces when the molecule is nonpolar, and dipole-dipole forces when the molecule is polar.